No.
One more try.
All right.
Double or
No,
nothing.
double or nothing. You had your shot at glory, man.
Double or nothing on the two straight down.
Oh no, you didn't get it. How sad. All right, here we go. So today we did our bell ring already. Went through tests, all sorts of great stuff. We're going to review how to solve inequalities. We're going to write interval notation. Have you ever done that before? Interval? Oh, great. It's a fun time. And then we're going to match number line graphs with solution sets. It really shouldn't be that bad. We do kind of a lot of stuff to get through those, so let's get through it. The first thing's already filled in for you. I'm just going to kind of talk about it. Interval notation is how we're going to write a lot of our answers. When we get down into second semester, we're going to talk about domain and range. We're going to talk about domain a lot, actually. And this is how we're going to write our domain. So we're going to need to know this interval notation, not just for this unit. Alright? So, an open interval is described by parentheses. So parentheses determine an open interval. An open interval is just like an open circle on your graph. It means that you are at that number, but we're not including it. Just like how we say when it's less than 1, we leave it an open circle, but we're still at 1. Same thing with a parenthesis. Parentheses just like an open circle. A bracket is a closed interval. It means you're including that number. So if it's like a less than or equal to or greater than or equal to, we're going to use a bracket. If it's just less than or just greater than, we're going to use a parenthesis. Alright? You can have half open intervals where one side's got that filled in circle or the or equal to. One side's got the open circle or not equal to. You can have half of each. We'll also talk about non-ending intervals. Alright, so anytime you draw an arrow, like those OR problems where we're going in different directions, they always go to infinity. We will write that. The infinity and negative infinity will never have a bracket around it. Never, ever, ever. You never include it because, is infinity actually a number?
No. Yes.
No, it's not. You'll never get there. It never stops. It's never a concrete number, so it will always have a parenthesis. Infinity and negative infinity will always have parentheses. If you're including a number or it's or equal to, that's when we're going to use the brackets. Alright? Kind of makes sense?
Yes.
We'll practice it, don't worry. Alright, so solve and write your solution in interval notation. This is how we're going to write a lot of our answers in this unit. Is we're not going to use less than or equal to, things like that. We're going to use interval notation. So, interval notation. First thing we got to do though is we need to solve it. It's one of those three-piece inequalities. What type of problem is it? It's an AND problem, right? We're going to have two stipulations it has to meet. First thing we're going to do is going to subtract 11. 25 less than or equal to negative 5x less than or equal to 55. Alright? Then I need to divide by negative 5. Liam, what happens when I divide by a negative?
You flip all the signs.
Flip all of the signs. So negative 5 greater than or equal to x greater than or equal to negative 11. But did we say we write it like that? No, we got to turn it around, right? Negative 11 is less than or equal to x less than or equal to negative 5. Alright, so that's how we've been writing. That's how we wrote it yesterday. Now we want to write it in interval notation. Alright? It's really simple. We're going from negative 11 to negative 5. And we need to decide, are we going to have brackets or parentheses? We're going to have brackets. Why, Mason?
Because it's equals to as well.
It's or equal to. We are including these numbers in our answer. So we know we're going from negative 11 to negative 5, and I'm including those two answers in my solution set. So I'm using brackets. And that's written in interval notation. That's my answer. Bracket, negative 11 to negative 5, bracket. Okay? Does that make sense? So then if I ask you to graph that, on my graph down here, I'm going to go to negative 11. Am I going to have an open or filled in circle? Filled in, right? We're including it. We just said that. Okay? I'm going to go to negative 5. Open or filled in? Filled in. And then I'm going to shade in between them. So I know I'm going from negative 11 to negative 5. Shaded a little better than me. It's fine. Okay? Any questions? That's not too bad, is it? Should we try another one? Alright, let's try another one. Solve and write your solution in interval notation. So now it's an OR problem. So we're still going to solve them now we're going to solve them separately. Negative 5b less than or equal to negative 60. Divide by negative 5. Uh-oh. Dividing by negative again. Make sure you flip your sign. B is greater than or equal to 12. Or, we got a second part. Got to find that second part. Add 12. 11b less than negative 88. Divide by 11. B is less than negative 8. So I have B is greater than or equal to 12, or B is less than negative 8. Now, I need to write that in interval notation. This one's not as easy as that AND problem. It's really not that hard once you think about it, but it's not as easy as just putting the two numbers down. Let's think about this. B is greater than or equal to 12. What is the smallest number in that set? 12. That's my number on the left. I'm going to put it over here, and I'll explain why I put it on the right in a second, but you can put it over there too. Okay, leave some room on the left side here to write the other part of your answer. So 12, 2, what's the biggest number it's going to be? Infinity. We don't know, right? B is greater than 12. It can be as big as we want. So we're going from 12 to infinity. Because side is 8. Going from 12 to infinity. Now, am I including 12?
Yeah.
Yeah, so I need to put a bracket around it. Do I get a bracket or parenthesis around infinity?
Parentheses.
Parenthesis. It's always a parenthesis. We're never including it. Alright, so we have that or in the middle here. Now I'm going to look at B as less than negative 8. What's the smallest that's going to be? B is less than negative 8. What's the smallest value I can get? Negative infinity. 2. What's the biggest number I'm going to have?
Well,
It's going to get up. We're not actually going to have negative 8, but it's going to get up to it, right? We're not including either of those, so they're both parentheses. Now, notice how we wrote that. These smallest numbers will always go on the left side. So, negative infinity, if you ever have negative infinity, it is always on the left. Farthest left. Smallest to largest. Alright? So that's my answer in interval notation. Does that make sense? Yeah, any questions? We're going to use interval notation a lot going through here. So
it can't be parentheses, negative 8, comma 12, bracket? That doesn't work.
no, because what happens on Mason is you're saying that we're taking numbers between negative 8 and 12. You're saying 10 would work. Well, is 10 greater than or equal to 12? Or less than negative 8? No. If it was an AND statement where we were talking about B is less than or equal to 12 and B is greater than negative 8, then that would work. But we're doing two different sides here. Alright? So I go to make my graphs. I'm going to start at negative 8. Not including it, so it's an open circle. Going to negative infinity, so I'm going left. 12, filled in circle, so I'm including it. 8's got a bracket, going to infinity, so it's going to the right. That's my graph. Alright? Does that make sense? Yeah? Try one more? Am I going too quick? Okay. Alright, so solving graph. First thing I'm going to do is I'm going to distribute both of these pieces here. Negative 6 plus 6x minus 4x minus 20. Less than or equal to negative 24. So all I did is I distributed first, right? Doing my algebra to solve it. Combine my like terms. 6x minus 4x is 2x. Negative 6 minus 20 is minus 26. Less than or equal to negative 24. So add 26 to both sides. 2x less than or equal to 2. And then divide by 2 to get x by itself. X is less than or equal to 1. Alright? So that's what we've been solving. That's how we solved it yesterday. But we want to write an interval notation. We want to write interval notation. So, what's the smallest number I'm going to get from that condition? Negative infinity, right? It's going less than 1, so it's going backwards. It's going all the way to whatever number I want. That's negative. So negative infinity. 2. Biggest number is going to be 1. Am I including 1? Yeah, so I'm using a bracket. So it's going to be negative 1 to, or negative infinity to 1. That's my interval notation. And then when I go to put it on my graph, filled in circle at 1, shading to the left. Alright? Any questions on that? Alright, we got a few more problems and a couple review. Alright, so let's practice some matching. We give you the interval, you got to match it to the graph. Is it going to be easy to match this? This? What are we going to have to do? Probably solve it to see it, right? So negative 5n plus 3n is negative 3n. 3 is less than negative 3n. Solve for n, divide by negative 3. I get negative 1 is greater than n. Because I divided by negative, I had to flip my sign. But I want to write with n on the left side. So it's going to be n is less than negative 1. Alright, well let's look at these. Which one is n is less than negative 1? Kenzie?
Top right.
Top right. Open circle at negative 1, going to the left. Top right. Try the second one. Try the second one. I'm going to do it on the board while you do it on your paper. We'll see how we do. So if you finish, you can check your answer with mine on the board. Let me know how we did. Good. So. Good? We good? Alright, I'll give you a couple minutes for some of the people who are still working. Okay. No. Let me get somebody. Alright, do we all finish that problem? Did we all get it right? Do we have any questions on it? Alright, then last thing we gotta do, let's review a little bit of how do we graph a line, right? There might be some problems, I think, on the homework tonight. And we're going to need it later this unit when we start graphing inequalities. So how do you graph a line? Y equals 3/4 x minus 5. Kenzie?
Put your first one at -5 and then...
At negative, over here?
Yeah. No, on the y-axis.
Oh, on the y-axis, so 0, negative 5. How do you know that?
Because that's the y-axis.
So y equals mx plus b. B is my y-intercept, so negative 5. I have a slope of 3/4, so go up 1, 2, 3, over 1, 2, 3, 4. Rise over run. And then use your straight edge to draw a line. I'm going to cheat. You guys, if you don't use a straight edge and it's like really janky on your test, how do you think it's gonna go?
Very good.
Good.
What? You think it's gonna go good?
Yeah.
Alright, try it. Probably get marked wrong. Make sure you're using some sort of straight edge. Use your folder. Use your ID card. Use your calculator. Some sort of straight edge.
I use my phone.
Alright? Well, then you get your phone taken and a 0 on the test. That'd be really great. Alright,
2-in-1 special.
y-intercept is at 6. Negative 4 over 1 is my slope. Down 1, 2, 3, 4 over 1. 1, 2, 3, 4 over 1. Draw a line. Alright. Those ones are easy, right? Y equals mx plus p. What about that last one? Has anyone done the last one yet?
You have to solve for y.
Wait, did we just do that last unit?
No.
Prefer not to.
Yeah, we just solved for y last unit.
No.
Oh my goodness, so solve for y, minus 2x, negative 4y equals 12 minus 2x, divided by negative 4. Y equals 1/2 x minus 3, so negative 3, up 1 over 2, up 1 over 2, and use your straight edge to draw on a line. That's a pretty straight line.
No.
Stop it, man.
It's not a straight edge.
Oh, it's.
You're right, it's not a straight edge.
So you get an automatic F?
Yep, give myself a 0, put it in the grade book.
Yeah.
I'm going to go.